let's have a look at an example involving percentage error. And I think this example will highlight the importance of why percentage error is in fact important to determine whether a measuring device or a measuring instrument is in fact appropriate. Okay, so the length of a room was measured using two different tape measures. Okay, the reading on tape measure A was 4.1 meters, and the reading on tape measure B was 4.10 meters. Calculate the percentage error of both measurements. Okay, first thing to notice is that tape measure A was measured to 1 decimal place. Tape measure B was measured correct to 2 decimal places. In other words, this implies that tape measure B was more accurate than tape measure A. So the first thing that we need to work out is what is the precision of both of these measuring devices. So precision of tape measure A. Okay, what's the smallest unit that it can measure? Okay, and because it works in tenths of a meter, okay, the precision of tape measure A is 0.1 meters. Hence, the absolute error is plus or minus, okay, 0.1 times half, or half of the precision. So the absolute error is 0.05 meters. Okay. So what would the percentage error be then? Okay. So the percentage error, okay, is equal to the absolute error, 0.05, over the measurement, which is 4.1, multiply that by 100. Of course, that'll be a percentage. If we multiply those two numbers together, okay, so 0.05, okay, over 4.1 times 100, and we get 1.22. Let's leave it to 2 decimal places, 1.22%. Okay, so slightly over a percent there. Okay, let's have a look at tape measure B now. Okay. Okay. Is equal to 0.01 of a meter, and that's implied by the number of decimal places that are used there. Okay, there's 2 decimal places, so it looks like it could measure basically in hundredths of a meter, which is centimeters. Okay. So the absolute error is equal to half of the precision, so it's going to be 0.005 of a meter. Okay. So the percentage error, so I'm just have this sort of running out of board space here. Okay, is equal to 0.005 over 4.10 multiplied by 100. Okay, and we could just use the same calculation. Okay, and I would expect basically a tenth of the previous answer, so 0.122 or 0.12%. Okay, so what does this imply then about our measuring instruments? So these are our two solutions. Okay, obviously tape measure B is far more accurate. Okay, basically a tenth of a percent out, whereby tape measure A, I'm a bit over 1% out. And if I'm measuring something, let's say for example, want to do a floating floor or measure up some carpet or something like that, being 1% or over 1% out could basically make or break a project. So probably when measuring a room, it could be arguable that over 1% or error could in fact be not accurate enough. So therefore tape measure B would certainly be more accurate. Tape measure A, by the way, is measuring in steps of 0.1 meters, so it measures correct to the nearest 10 centimeters. I think that in itself would probably imply maybe not the most appropriate, but we're measuring 4.1 meters, so that's fairly long. It's a long enough length to say, well, it's sort of arguable whether that's accurate or not. But most certainly, tape measure B, I think for this application, tape measure B would certainly be accurate enough, I would say.